Good morning, everyone. All right, so today we'll be talking about reliability engineering, systems thinking, and career development for mid-level engineers. I'm specifically targeting mid-level engineers because there's so much content already available for junior engineers all the time. They're flooded, but then once you leave from being a junior engineer and you're like starting to get into mid-level, there's not often like guidance on like how to actually progress to like senior engineering and things like that. So I'm SJP. My name is Stevenson Jean-Pierre, but I go by SJP. Like our wonderful host mentioned, I work for a company called PagerDuty. So if you've ever been on call, y'all probably know PagerDuty. PagerDuty keeps you up at night, keeps you nice and comforted. If nobody else is hitting up your phone, at least PagerDuty's hitting up your phone. So that's always good to know. So I've been in tech since 2007. I've worked with numerous organizations to like help build and scale their infrastructure organizations as well as secure their organizations. I've been a hiring manager on multiple occasions. I'm currently a senior engineering manager, and my hobbies include woodworking and photography. So the key question that we're trying to ask today is, can the principles of site reliability engineering and system thinking help engineers level up in their careers, or software engineers that aren't specifically focused on site reliability engineering? Can some of those principles of site reliability engineering help them through? Okay, so first let's just describe what reliability engineering is. So y'all probably have SRE teams at your company. They're responsible for things like the core platform, the core compute platform, core databases, and things like that at your company. The practice of SRE was just operations people adopting software engineering practices in order to be better at operations. But the inverse of that is like, how can software developers adopt some operations mindsets to be better engineers themselves and think more holistically about their systems? So we all know reliability matters. We all know some of our favorite services have outages sometimes, and we hate when that happens. Our customers also hate when that happens. And as software engineers, part of our job is not only to produce the software, but also to make sure that we're producing the software in a way that optimizes for reliability and scalability and things like that, so that our customers, our end users, could have the best experience possible when they are interacting with our services. So we all know that failure is inevitable. What's important is that as we fail, as we have the failures in our systems, that we're actually learning from the mistakes that happen. We're learning from the failures that occurred, and we analyze the reasons for those failures, and we come out with better systems in the end. If we keep failing for the same reasons and we don't actually learn from those mistakes, then we're wasting time and effort from our teams. So as we learn from our failures, as we encounter failures, what we should end up with are more resilient systems. We shouldn't end up with just as fragile as the system that we had. If we've been running a software service for 10 years and it's had 10 years of failures, at the end of that process, we shouldn't be having the same exact failures over and over again, right? We should be able to take those learnings. We should be able to see those things that failed. We should be able to extract patterns from those failures, and at a high level, start tackling those type of failures at a more holistic level, so that we not only improve that particular software, but as engineers, our mindset that we take to the next companies that we go to the next projects that we go to, we start pre-thinking about these type of failure modes. We can say, oh yeah, I remember when we did this certain type of full table scan or something like that, that causes the database to be unhappy. So the next project I work on, I'm gonna make sure I'm using the right indexes. I'm gonna make sure that I'm not doing full table scans. I'm gonna make sure that I optimize for that layer, so that as you go through your career, that starts painting you in a different light, because you have this bundle of experience that you've kind of accumulated over the years, and you could level up your career. So I also mentioned systems thinking at the beginning of the talk, and it's this kind of ambiguous kind of concept, but there's like certain parts of system thinking that I think would definitely apply to software engineering and will make engineers better at their jobs if they take a more holistic view of the systems that they work on. So the definition of systems thinking is, like I said, just this mindset of like thinking about things as all being interconnected, no matter if you're talking about the software systems themselves or the processes that are used to deliver the software systems. Everything is interconnected. Everything has like these associations that could lead to different outcomes, right? So if you start taking a systems kind of thinking mindset, you start kind of zooming out and you think about all of your systems in a holistic fashion, whether it's a process or whether it's a software service. Like everything has like risk and rewards, pros and cons, and you have to weigh those things if you're taking that mindset to understand how to best leverage those learnings and apply them holistically. So why system thinking matter, right? I really love this particular graphic because it's about when we're junior engineers, we tend to think tactically, right? We play this game of whack-a-mole. Somebody assigns you a bug, you fix a bug, you see just that level, or you tend to not look broader. You see a particular bug, you work on it, you're happy that you got your ticket resolved, but you don't necessarily think like, hey, is this bug part of a class of bugs or part of a system of bugs? Or like you zoom out and you see like, oh, there's a pattern here. Yes, I fixed this validation issue here, but do we have the right frameworks in place? Do we have the right kind of abstraction layers in place to make sure that validation is consistent across our application, right? But as junior engineers, we might just be like, yep, fixed password validation over here. I didn't really think about other areas that might have it. And what you end up having is 6, 7, 10 bugs of the same variety over the months that could have been addressed if you would have taken a more holistic approach to your thinking and your patterns, right? So when we think about systems thinking and why it matters, we want to not only focus on the tactical, but we want to zoom out and look at the strategic kind of nature of things. We want to think of our system as a whole instead of focusing on the individual events that occur. We want to start extracting patterns and trends from that and act on that. So as engineers, you become extremely valuable to your organization because you're not just somebody who's shifting tickets, but you're helping the organization mature because you're bringing these ideas, you're bringing more maturity to your software processes, you're bringing more maturity to the software systems that you deliver. So we're going to take a systems thinking mindset to one of the tragic failures that happened to the empire. The untimely demise of the Death Star, right? So we had this situation, and it's easy if you're taking just a event-based approach to be like, yup, it was that exhaust port that was the root cause, like nothing else could have mattered there. We just should have we should have put a patch over that exhaust port and everything would have been fine, right? But if you take a system thinking approach, if you start asking the right questions and you start trying to extract patterns, you'll find that there's more to that than just it was the exhaust port in this particular situation. So one of the methods that I really like to use and that's been kind of discussed on blogs and stuff like that is that whenever you're doing incident analysis, right, there's this concept of the 5 whys, right? You don't just stop at the first why by saying, yep, it was the exhaust port that was bad, we should have just covered it up and that would have been fine. As you dig into issues, as you try to reflect on issues and become more strategic in the way that you think, you should be digging in further and further into the problems that occur to try to extract patterns and try to understand on a more fundamental basis why these things happen. So, sorry, go back. So in this case, right, we start off with the problem, which is the Death Star was destroyed. But as you dig in, you realize that the ultimate reason why, if you ask yourself all these whys and you start extrapolating from these patterns, you find out that the ultimate reason why is we were not we, okay, I'm not part of the empire, I'm part of the rebellion, but they were overconfident in their capabilities. They didn't think they would be attacked in that way and things like that, so they might have rushed the design of the Death Star, right? They might have taken some shortcuts because they didn't think that would be an issue. Or they weren't given enough time to actually do proper thermal management, so they just put this huge port on the end of the Death Star in order to get heat out. But if you take the same approach with your software systems, right, when you have failures, if you really dig in to try to understand fundamentally what were the contributing factors, like I don't like the idea of just purely root cause, right, because saying root cause means that, oh, there was this one thing, there was this one silver bullet that led to an issue, but in reality, it's usually a system of failures that occur by the time you get to a failure condition, right? So when you think about it more holistically and you start really digging in, you realize that yes, there may have been a bug, but this bug didn't exist in isolation. This bug was a result of a number of processes that failed before you got to this place, right? So as you dig in, you start being able to improve your processes. You start being able to, yes, address this tactical thing, but more strategically, you start to produce an ecosystem that also helps people that come in the future that may not have the exact experience that you have or the exact knowledge of this particular failure to not slip on the same exact things. So other parts of system thinking and why it matters is that it allows you as a team to be better, right? You don't have to rely on like tribal knowledge and you don't have to rely on like individuals knowing things. You start producing systems of work and systems of processes that help safeguard things. They produce guardrails, they produce these kind of systems that allow everybody to succeed within your team and within your organization. And as an engineer, if you're the one pioneering some of these ideas, if you're the one pioneering some of these like thought processes and making sure that you're not only solving for the tactical situation, but you're also taking the time to solve for the more strategic or the high level situation, that definitely paints you in a better light as an engineer to your leadership and to your organization, because they can see that you have this quality that goes beyond just what we usually describe as like soft skills or hard skills, right? Like hard skills are, yes, you're a great programmer, you could write great code, but at the end of the day, as an engineer, we deliver so much more than just the code that we write. Sometimes the code that you don't write is more important, right? So if you take a strategic mindset, if you take a holistic view, sometimes you can realize we don't actually need to write code to solve this problem. There's another business solution that we might be able to apply to avoid a system in the first place. So I want to also talk about some of the SRE concepts that we could pull back from SRE organizations and apply to software development that maybe will help software developers think about their systems better and incorporate into their workflows, incorporate into their organizations better maturity models that they may not have yet. This is especially true when folks are working at startups, when we all know, like when we work at startups, it's extremely just like, we'll tackle things as they come, right? Like we don't necessarily know exactly how mature we need to be. We're just trying to move fast. We're trying to deliver the solution that we're trying to deliver. We're trying to make sure that we could raise our next round. So you'll see that if you transition from these more enterprise companies to startups, it's like, wow, it's the Wild West over here. You're just, YOLO everything. We're pushing the production straight up. Like you don't like necessarily have the kind of guardrails and safety mechanisms in place because y'all just don't have that level of maturity yet, because either you haven't seen these particular type of problems before, or we haven't had a need for it because these are like things that would potentially encumber the processes of delivering software fast. But as you mature as an organization, there are certain processes that you're going to want to apply because they make your organization more resilient, they make your systems more resilient, they make your processes more resilient. So the first one is just tracking your mean time to resolution, right? You could have plenty of incidents as an organization, you could have plenty of situations where your software fail, but understanding how long it takes you each time on average to resolve the issues is a great proxy to determine how well your systems are understood by your engineers. If constantly you're having failures and it's taking hours for your engineers to even figure out where things have failed, and then more hours to figure out exactly how to resolve it, that should indicate to you that as an engineering team, we may not have great understanding of our systems. And we all know that sometimes we write software and then we're baffled by our own kind of experience of the software because we're like, how could it do that? We wrote it in a certain way. But these are emergent systems, right? The individual components don't act on their own. They interact with broader ecosystems and they produce results sometimes that we don't expect them to because of that interaction with everything. So when you take a systems thinking mindset, when you take this reliability mindset, you look at things holistically and you start like gaining a better understanding of your software. You start gaining a better understanding of like your mental model should be evolved where you start thinking about how data flows through your software, how processes flow through your software, and how to best optimize for better results. So by tracking mean time to resolution, you start being able to extract like this pattern and understanding like if we're taking longer and longer, if we consistently take a long time to understand what the failure is and how to fix it, there's something fundamentally wrong with our mental models about our software, and we need to reevaluate how we think about our softwares, and maybe sometimes it's about reducing complexity. Maybe there's too many things going on and we're unable to necessarily figure out or step through our own kind of mental models for these systems. Another concept from SRE, from site reliability engineering, that I really think every engineer should like deeply be involved in and like really care about is just incident management life cycles, right? You have incidents, but all too often people are like, yes, let's fix this bug, let's bring the site back up, and as soon as the site's back up, they pop champagne and they're done with it, right? They're like, well, we're off to the next thing, we're back to regular story mode, we're back to our regular sprint. But what should happen is that you have an incident, you have a failure, yes, you do whatever's necessary to solve the tactical issue at that moment, you bring the site back up, but in the following days and weeks that come, what you should do is a full analysis, understand why your system failed, understand why your processes and what you had already from monitoring and alerting and other things like that didn't potentially catch the situation, understand what you could do in the future to either catch the situation faster, catch the failure faster, or remove that class of failure entirely, right? So the idea that incident management is a responsibility of site reliability organizations alone is one that we should move away from, and we should make sure that every software engineer is like fully committed and involved with the process of incident management life cycles and with the process of incident reviews and like really drilling in, using that 5 whys that we discussed and like really drilling in to understand the failure and making sure that you solve the problem tactically for that particular software that you're running, but also you look more holistically across the rest of your systems. How many other services do you have in your ecosystem might be vulnerable to the same exact failure type? Are you actually addressing that holistically and making sure that you learn this lesson once and you applied the solution broadly to make sure that you're no longer having to incur that same issue? SLOs and SLIs. So a lot of teams, like I mentioned, if you're from startup culture and things like that, there's a lot of things that just go unmeasured, right? Your measure of success is like, my software's up, I'm getting customers. But as we take a more holistic view of our systems, what we want to be able to start saying is like, I have an objective for availability and reliability, and I'm able to measure that objective. I'm able to know exactly how much of the time I'm able to deliver my software properly to my customers in a reliable and performant fashion, right? So by having KPIs like SLIs and SLOs, you're able to not only kind of establish where you want to be, what your objectives are, but you're able to have the data to back it up. You're able to have the data to prove out how well you've been able to achieve those goals. And then when you find yourself actually falling short of those goals, what you do is you pay down technical debt, right? You look at these metrics, you're falling short, you start incorporating stories into your sprints that try to address some of these reliability issues that you may be having. Not everything turns into a full-blown incident, but you might have pages that slow down beyond what you wanted them to be and things like that. So having SLOs defined for your critical workflows mean that you start being able to measure these things and have metrics to back them up so you know when you're reaching a point where customers may start getting unhappy and preemptively resolving those issues before it becomes a broader issue. So this is one of the graphics from back when like DevOps was the buzzword, right? But I think it still matters a lot because a lot of developers think of themselves fully on the left side. I guess it's the left side. I guess the slide looks the way it looks for me. But on the dev side of the kind of loop, right? So they're like, I build the software, I'm just shipping code. By the time it gets to production, that's somebody else's problem. By the time it's running and we need to like maintain the software, that's somebody else's problem. But we're gonna maintain a lot more software than we write in our lifetimes, right? Because we're not writing these things to rewrite them every 6 months or every 3 months. So at some point, we need to get in the mindset as senior engineers, as mid-level engineers going towards senior, that it's more important to make sure that we're building reliable and efficient systems that we can maintain in the long term rather than just being like self-congratulatory for building systems and shipping fast and stuff like that. It works out when you're just like hopping company year to year, but at some point you have to like settle down and be somewhere for a while and like all those kind of seeds that you planted come to harvest, and it's like, oh, all these reliability issues that I pushed out that I didn't worry about, they start being issues. So getting more into the full life cycle of your software delivery life cycle and making sure you fully understand what it means to not only produce software but maintain software and run software in the long term means that you're able to be just that much more valuable as an engineer because you take this mindset that it all matters, right? That I need to focus on every aspect of our software delivery life cycle and make sure we optimize it. Okay, so we talked a little bit about that. Like, how does this actually apply to your career? How does this actually apply to you becoming a better engineer? How does this help you level up as an engineer? I think we have a pretty competitive like playing field when it comes to like just people in the industry and stuff like that. I think when you are a junior engineer that's transitioned into that kind of middle purgatory place where you're like, I'm not quite a senior engineer, but I'm also not a junior engineer. How do I differentiate myself as an engineer? How do I make sure that when promotion time comes around, I'm not just talking about the bugs that I fixed or just the small tickets that I pushed. I'm talking about more holistic achievements that I had as an engineer. I think taking that systems approach, taking that reliability approach helps differentiate you as an engineer because a lot of people just aren't thinking that way. They're just thinking about the code that they ship, they're thinking about the lines that they write, and that's the like extent that they're measuring things to. So y'all have probably seen this kind of described. As an engineering manager, I love to try to mentor my engineers and help them build out their skill set, right? So when we're junior engineers, we start just trying to build like this broad kind of base of understanding of our systems, right? Some people go I-shaped, which is like I go deep in one area, and then that's the only area I know. I'm not a person of all trades or anything like that. But some people start off with the kind of broad area first, where they're just like dabbling in each respective area. And as you progress in your career, you start being T-shaped, which is what most people describe as like what they want to be, right? They want to be T-shaped. They want to be able to go deep in certain areas, become subject matter experts in certain areas, but also go broad and know what's going on. But what's really ideal in my mind is being that cone-shaped engineer, right? You have the deep technical kind of veins in the kind of cone, but you also can reason about and discuss and articulate about a broad scope of things, because these things matter when we deliver software. No software works in isolation, right? You can't just focus on like, I don't know, compiler optimization and think that you're going to be able to deliver full, kind of software solutions. You have to be able to dabble in each area. But one thing I think this particular type of graphic misses is that we talk about often soft skills and hard skills. It's like you're a great programmer, you're a great collaborator, you're a great communicator, and those are like the only two kind of aspects that we talk about. But when we talk about some of the best engineers that we ever worked with, sometimes it is definitely like their ability to collaborate, it's definitely their ability to code, but there's something that's always like this missing piece that's like, that differentiates like some of the best engineers that I've ever worked with compared to like some of the engineers that are just okay. And usually it's because you could go to these people with problems and somehow, without even seeing the thing, right, they just know like, oh, they have this like mental model of these systems, they have this kind of systems thinking about these things, and they can help you achieve a solution by asking the right questions. So I'm imploring y'all to like take some of those same kind of mindsets around things. Don't just focus on the kind of shuffling tasks and shuffling tickets or some of the other things. Like, make sure you're taking this holistic approach to the way that you deliver software, to the way that you think about your systems and processes, and try to improve them like on a broader scale. That's all I had for today. Thank you all for coming.